Hello everyone, welcome, and on behalf of Transoft Solutions, I welcome you all to the third webinar in 2019 AutoTURN Tips webinar series. For those of you who don't already know me, I'm Charles Sebastian Chalisheri, and I'm a civil technologist with Transoft Solutions, working in the product management team within the simulation business unit, which takes care of the AutoTURN family of products. Today, I'd like to present to you how AutoTURN helps analyze safe emergency vehicle access. This presentation shall be approximately 30 minutes long, followed by a short 15 minutes question and answer session. If we are not able to address your questions during the Q&A session, we will send you the answers by email. At the end of this presentation, we would like you to complete a 2-minute survey, as we really appreciate learning more about our customers and how you use the software. With that, let's jump right into our presentation. So here goes the agenda for today's webinar. I will start the presentation by explaining a bit about emergency vehicle access and the major design techniques adopted on the streets and access lanes to facilitate proper emergency vehicle access. Then I'll briefly go over the importance of swept path analysis for emergency vehicles and the consequences caused by an improper design. Then we shall see how AutoTURN benefits in proper designing and analysis for the emergency vehicle access. After which we'll jump onto the technical demo, focusing on a scenario where AutoTURN analysis will help propose a better redesign for the site with minimal changes. After the demo, we'll talk about the project support services and move on to the question and answer session to conclude the presentation. By the way, feel free to ask questions throughout the presentation. So, the fire department in a region has to respond to different kinds of emergencies in various types of buildings and occupancies. These include houses, apartment buildings, shopping malls, business and industrial complexes, hospitals and nursing homes, etc., and many more. So to provide effective firefighting operations, the fire department must be able to reach all these structures by way of an approved access, which may be roadways, streets, or driveways. Hence, any new construction or developmental projects require to analyze the route of the emergency vehicles from its base, which is the fire stations, to the point of emergency for unrestricted access. These routes may include both the streets as well as the emergency access lanes. So the emergency access lane or fire lanes are drivable access with a stabilized surface that allows access for emergency vehicles, including fire vehicles, police vehicles, ambulances, to a particular property. There are some design criteria that has to be followed while designing the streets as well as the fire lanes in order to be compliant with the requirement of the fire departments in the respective regions. So the various different street design techniques are adopted in order to accommodate the uninterrupted movement of an emergency vehicle while slowing traffic speeds. These include parking placement strategies, like on single side or both side, depending upon the clear width of the road available. Mountable curbs, like in curb extensions, roundabouts, traffic circle, medians, etc. Implementing roundabouts, which helps in reducing the stopping and waiting delays at intersection and stop signs. The use of appropriate traffic calming measures. And another important factor is the selection of right type of vehicle. This is in order to facilitate quick and easy access to the point of emergency. Emergency access lane design include providing proper clear width for the road and proper turning radius. Most of the guidelines specify a clear width not less than 20 foot and a centerline radius not less than 42 foot 6 inches. Another factor is to provide proper driveway grades. Most of the guidelines recommend to consider a grade change of less than 1 in 12.5 over a length of 15 meter to be favorable. Ensure stabilized pavements and proper thickness for the pavements so that even heavy vehicles like the fire trucks can access the location without any difficulties. Provide easy access to the fire hydrant hookup locations. And also the lane should not terminate in a dead end. And if it does so, we should provide proper turnaround facilities like a hammerhead turnaround or proper width for the cul-de-sac so that the vehicle can make a turn without stopping. Also, no parking shall be permitted on the right of way. As we all know, fire truck is the largest emergency vehicle that will need to access to the point of emergency. And as most of the design guidelines does not include fire trucks as a design vehicle, the fire departments either propose to use a larger sized bus or truck to represent these vehicles for swept path analysis. Or they might have an actual dimension for a vehicle which might be the largest vehicle in their fleet, like the one shown here. So this particular ladder fire truck was created in AutoTURN as one of the standard maneuverability analysis vehicle for the Chula Vista Fire Department in California. The authorities also strongly recommend that all major development permit applications should include a swept path analysis as a part of fire access plan. Most of the fire departments custom order their new fire trucks, which may be according to their requirement or use, like the aerial, pumper, rescue, or the tanker truck, maybe to function effectively on their existing streets without much modifications, and also to accommodate them in their existing infrastructure, which may be old fire hall buildings where the design widths and heights might be shorter than the present-day modern designs. Few examples of these are the city of Milwaukee, which purchased fire engines that have excellent turning radii specifically for their older neighborhoods. California ordered highly maneuverable fire engines for use on existing narrow streets in their hillside neighborhoods, like in the San Francisco. The department that responds to fire and emergencies in rural and wilderness areas, especially in the rugged mountains and forest terrains, often purchase vehicles that are designed to handle narrow roads and tracks. Hence, underlies the importance of checking emergency vehicle routes with a specific vehicle that has access to the area rather than any vehicle. Emergency vehicle response time is a critical factor and is directly affected by poorly designed roadways. So you might have seen headlines in newspapers or TVs which says a fire truck gets stuck in a rural driveway or a fire truck gets stuck backing up an alley and so on. These situations result in loss of time, energy, efforts, cause damage to the infrastructure, damage to the vehicle body, and in worse situations may also result in loss of lives. The most common issues faced by the emergency vehicles are ground clearance issues, overhead obstacles, body clearance issues, unstable terrains, ladder deployment obstructions between the fire truck and the building. If roads and access lanes are designed properly to accommodate emergency vehicle access, it would help avoid unnecessary delays and the response time may be improved, which in turn benefits the efficiency as a whole and also result in less casualties. So AutoTURN's 2D and 3D tools, together with the vehicle creation tools, help us model the exact vehicle and perform a comprehensive analysis for checking body clearances, ground clearances, as well as overhead conflicts in order to evaluate the feasibility of the design and also ensure unrestricted access to the site. So the SmartPath tools in AutoTURN helps us check the swept path of a vehicle before and after the street design modifications are adopted, like the traffic circles, roundabouts, traffic calming techniques, etc. It also considers the effect of speed, superelevation, and friction acting on the vehicle. The Telepath tool in AutoTURN Pro, which is an automated swept path creation tool, automatically creates a swept path once a route is defined. And once a particular route is defined, we can check for multiple vehicles by just creating one maneuver and easily swapping different vehicles that have to be analyzed. It also calculates the maximum speed achievable by the vehicle for a particular maneuver, which can dictate if the design change actually resulted in lowering vehicle speeds for like the traffic calming projects without affecting the emergency vehicle access. This also helps saving time and efforts. Also, with the sophisticated vehicle creation tools, which allows the modification of most of the vehicle parameters, including the chamfers and notches of the vehicle, and advanced features like custom created profiles and templates for the outer body modification in AutoTURN, we are able to define the vehicle body with an accuracy close to real-life vehicle models. With that, let's jump on to the demonstration. Today, we shall be seeing a scenario where AutoTURN analysis will help propose a possible better redesign for the site with minimal changes. This was possible by analyzing the area with the right exact vehicle. Before starting the demonstration, let me show you how to find emergency vehicles in AutoTURN libraries. So, as you all know, all the libraries and vehicles are contained within the vehicle tool in the ribbon. Let's open the vehicle tool and you can see the libraries. Now, in order to search for a fire truck, let's sort the library according to class and search for fire trucks. So we have three different fire trucks here, which is aerial, pumper, and rescue fire trucks. And you can see that we have the fire trucks from different regions like Australia, Europe, and North America. So if you have to sort according to the country, we can do that here. So we can select the type and select the region. So now let's go back into our presentation. So this site is a proposed housing development site plan for an age-restricted community. It has 30 living units, and the emergency vehicle access check was critical because most of the residents were old-aged, and also there is only a single road access to the site. So the preliminary design was submitted by the developers by testing the roadway, the roundabout, and the hammerhead for a standard pumper fire truck, which is larger than most other emergency vehicles like the ambulances and the police vehicles. So, as I explained earlier, we can create the exact vehicle in AutoTURN. So let us do the analysis with the standard pumper fire truck. So let's navigate to the custom library where I have created the fire truck. It's the standard bumper. So we can easily create a vehicle from an existing model in AutoTURN by modifying all the factors or the parameters associated with the vehicle, which includes the length, width, wheelbase, overhangs, steering lock angles, etc. So this fire truck is made to match this vehicle over here, which the analysis was done exactly. So now select the vehicle, click OK. Let's drive the vehicle into the hammerhead from the south. And let's see how the vehicle behaves. So it was found that the roundabout and the roadway could accommodate the vehicle, but the only issue was with the hammerhead turnaround, where the city was not satisfied that the proper fire truck could turn around. Let's see how the analysis would have been done. So as far as it can go, it has to be backed up to this and to the front. So here you can see that it doesn't cause any conflict with the nearby property or their driveway or their boundary or anything. So the standard fire truck, the bumper fire truck, satisfies the hammerhead. So I've taken the screenshot, closer screenshot to make it more clear. So the officials for the approval was the city and the fire departments. And the final approval was pending as the fire department wanted their largest truck in their fleet to be analyzed for properly accessing the hammerhead, which was an aerial ladder truck, which was indeed longer and wider than the standard bumper truck, which the developers used to test the site with. So the normal practice would have been to check the route with a larger truck from the AutoTURN library, which is the guideline, which is the prevalent guideline in US. So let's see how checking this hammerhead with an SU truck, like a single unit truck, would work. So let's navigate to the AutoTURN library. And let's use a larger single unit truck, which is the SU40. Let's do the same maneuver. Sorry, my last simulation was wrong. So let's check with a better speed. And this truck would have taken this path and backing up right away, it's clear that the truck won't make the turn back from the hammerhead. So hence, if we were to check this particular situation with an SU truck, like with a single unit truck that is a larger vehicle, then this design fails and has to be redefined, which may also affect the two dwelling units or the houses because it's encroaching into their private space. So the best possible option for analysis would be to create the exact vehicle, which is the aerial ladder truck, with the fire department. So as I already explained, in AutoTURN, we can modify the vehicle accurately by changing the length, width, front overhang, wheelbase, tracks, etc. So with some minimal research, I found the specs for this aerial ladder truck from the fleet of the fire department and copied a similar aerial ladder truck in AutoTURN and modified its dimensions to create an exact vehicle. This is the aerial ladder truck that has been created. Select the vehicle. Let's do the same maneuver with this larger vehicle and see how it behaves. So the turning capabilities are better than the single unit truck, but you can still see that even though it's not encroaching into the property, it's still blocked by the driveway. So consider in an emergency situation when the vehicle has to back up and turn out from the hammerhead, if there is a car parked in the driveway, then the fire truck would have to do more or furthermore multiple back up and forth, and only then it can get out of the hammerhead, which is not a desirable solution. Hence, we can test the same truck for minimal changes to the design. So I increased the hammerhead length to the west by 3 foot, to the east by 1.5 foot, also increased the width at the east side by 1.5 foot, and I kept the radius the same, which is R40. And let's try the same vehicle, the same maneuver. So clearly, it doesn't encroach any private driveway or private property, and the yellow lines, which are the tire treads, stays within the asphalt area of the hammerhead. So this is how AutoTURN helps to propose a redesign with minimal changes to the site. So this was possible because in AutoTURN we created the exact vehicle and we performed accurate analysis, and then we proposed best possible redesign with the minimal changes. All of these collectively helps us save time, efforts, resources, and credibility. Thank you. Now let's jump on to another scenario. So this is a different scenario to explain the use of Telepath Tool, which is a tool only available in AutoTURN Pro. So let's see how this tool helps us save time and efforts. So this is a typical site circulation scenario for a hospital complex. And there are two main entrances, A and C, for the emergency vehicles, and multiple routes to different entrances in the building, which has to be checked for emergency vehicle access and also other vehicles. So the basic steps in the analysis include selecting the area for analysis, selecting the non-drivable zones, which are the areas or which the vehicle should not pass through, or non-drivable lines, which is also called as exclusion lines. We can also select lane lines. That is, if there is a two-way road, we can select lane lines to define different lanes in the roadway. So in order to analyze this area, let me add a new area, change the name to my hospital or any other name, click OK. Now let's select the analysis area. Before that, Telepath Tool can detect lines polylines as a selection, but closed polylines are preferable and makes the analysis easier. So I have converted the boundaries into closed polylines beforehand this presentation. But it entirely depends upon the projects or the difficulty in the site if we have to convert all the lines into a polyline or just leave it the same. So let's select the analysis area, which is this whole area. And now let's select the exclusion zones, which I do not want the vehicle to drive over, which includes this roundabout as well, and this area, this roundabout, and these islands. So once the site is created, then it's just a matter of selecting whatever you want to. Right click to end the tool. So now let's pick some exclusion lines. This is the boundary to the parking, which I do not need the vehicle to drive over. So that's done. Right click to end the tool again, and lane lines, just want to mention a lane line here so that both vehicles can pass through and then other one can stop by in order to drop off people. Or now the setup is ready and we have to add different routes. So in this particular scenario, my first route that I would be analyzing would be around this roundabout where the vehicle drops off someone and just leave outside the hospital complex. The second route of analysis would be here, where I have to see if the vehicle can access the entrance E2. We have to click in the points in between to exactly align the routes. Let's add one more route, which is from here around the roundabout and outside. Now let's add the movement by selecting the vehicle. So now our default vehicle is always selected by the tool, and it is our aerial ladder truck, the largest vehicle which we checked for the last site. So let's use the same vehicle. Let's use the vehicle body envelope. So we can either check the tire treads or the body envelope. So let's check the body envelope. And now we have to place the vehicle and click to place the vehicle and orient the vehicle properly. Now click the last position and right click so that the tool will automatically calculate this maneuver and create the simulation without exceeding any parameters of the vehicle. Let's create another movement with the same vehicle. So the vehicle body envelope, click OK. And let's use the same starting position. And you can also set multiple positions if we want the vehicle to pass through those. Exactly. And then I'm ending it here. And I right click. The tool automatically starts calculating the path. And here you can see that the vehicle did not reach the entrance E2, or it has failed. At 6 miles per hour, this maneuver has failed. So if you want to edit this, let's try the front and rear tire envelope. If that satisfies the maneuver, click OK, and it automatically updates. And yes, so if there is a mountable curb or a low curb that the vehicle body overhang can pass over, then this maneuver can be satisfied with this particular vehicle. So that's how easy to use in Telepath. Let's add one more moment. So this time, yes, let's select the vehicle and let's use a body envelope. Click OK. Now let's select this route here. click and orient the vehicle, click and right click. So the benefit of Telepath is that it calculates within the few seconds, it calculates all the details to create a simulation in the background. So here, this vehicle is again failed. So let's try a different vehicle. So if you want to change, so if you have to check the same route with a different vehicle, it's so easy. Click the vehicles and select a different vehicle. So let's do the standard bumper, and with the same vehicle body envelope and with the speed, let's click OK, and it automatically updates the simulation. So this vehicle can pass through the roundabout properly. Now, there's also another functionality which may not be so relevant in the site circulation analysis scenarios, but which is relevant in determining the maximum achievable speed of a vehicle in traffic calming projects in the city. So there is an option within Telepath to have determine the maximum achievable speed for the vehicle. So let's try that. Just double click to edit and click OK. So it automatically updates. This takes a bit longer as the tool goes through multiple iterations, checking from a lower speed to a maximum speed, which the vehicle can pass through this maneuver. So here we can see that the maximum the vehicle can travel is 8 miles per hour. So with this, so the Telepath tool, sorry, the Telepath tool benefits us that it helps calculate all the parameters of the vehicle, and it creates a simulation with few clicks. So it helps saves time and our efforts. So the benefit of AutoTURN Pro in total is that it has various tools like adaptive simulation, smart path tools, and Telepath, etc., for generating smart maths for any different situations. With that, let's go back into our presentation. So the project support services team of engineers at Transoft Solutions offers the custom vehicle creation service to help you model unique vehicles like fire trucks or special transport or construction vehicles which are not currently available within the AutoTURN's vehicle libraries. So for example, if you want to model a specific vehicle from a manufacturer or a design vehicle from a road design guideline, we can create this vehicle for you for a small fee, and you can perform an accurate analysis on the site. So if you're interested in availing this service, simply contact our engineers at pss@transoftsolutions.com and provide them the required vehicle information, which is the vehicle dimensions, steering characteristics, profile drawings, etc. And based on this information, we can provide you a quote and an expected delivery time of the vehicle. So before I finish, I would like to let you know about upcoming Transoft webinars. So on March 27th, we are back. We are coming with GuideSign Plus, which is a new version release, which is a 7.1. This is all about how you can reduce your design time for roadway planning and also lane marking and stripping, etc. So all the 80 tips webinars, the AutoTURN tips webinars, are held in the third Wednesday of each month. And we are back next month with the tips webinar, which is all about evaluating the quality of a swept path analysis. That is mostly on how to check that a simulation you're shown or given is done correctly. Feel free to get in touch with us with any questions or inquiries. Our global technical support, which is open 24/7, is support@transoftsolutions.com. And our sales at North America is sales@transoftsolutions.com. With that, we have come to the end of today's session. Thank you very much for attending this presentation. Now, I would like to open the floors to you all. Feel free to ask any questions you have about any features in AutoTURN or Pro. I would be happy to answer your questions. Thank you.